Welcome Math 136 students to the Module 03B problem of the week. So for this problem, we are asked to find a polynomial functions when we are given the zeros of -2, +1, +3, and the graph passes through the point 2, -16. So I equate this to playing Jeopardy! In Jeopardy! Alex Trebek gives you the answer and the contestants are asked to find out or asked to give the question as a response. And so that's this case exactly. We are given the solution or the zeros to the polynomial function. And what we're being asked to do is reverse that process to come up with the particular polynomial function that gives us these zeros. So here's what we need to know, or here's what we hopefully do know at this point from understanding the process to get the zeros. That if x minus r is a factor of the polynomial function, then x equals r is a zero of the polynomial function. So that's what we know. So if we know that x equals -2 is a zero, that x equals +1 is a zero, and that x equals +3 is a zero, then the factors that produce these zeros are x plus 2, x minus 1, and x minus 3. And so now we can put these into a function format where we have f of x is equal to x plus 2 times x minus 1 times x minus 3. And it wouldn't it be so nice if that's all we had to do, but no, there's more. So first of all, you hopefully noticed that I left a blank in front of the first factor. And that's because traditionally, what we have is a variable a, or a letter a, to represent the leading coefficient to our polynomial function. And that's the part that we're missing. We don't know that leading coefficient, and that is why we are given the ordered pair of 2, -16. So what we will do is replace the x variable with +2 and replace the output, or f of x, with -16. So what we have is -16 is equal to a times 2 plus 2 times 2 minus 1 times 2 minus 3. And we're going to solve this for a. So we'll have -16 is equal to a times 4 times 1 times -1. Find the product on the right side to simplify. So we have -16 is equal to -4 times a. And then we divide to get our final answer for a. And so a is equal to +4. So again, wouldn't it be nice if we were completely done with this process, but we're not. So let's go off to the right side here, and let's now finish the problem. We know now that f of x is equal to +4 times x plus 2 times x minus 1 times x minus 3. What we need to do is simplify that function. So we're going to start by multiplying or distributing the binomials. So let's choose two of them. So x plus 2 times x minus 1. We can use the distributive property, or some of you like to refer to that as foiling. So x times x is x squared. X times -1 is -x. 2 times x is +2x. And finally, 2 times -1 is -2. Rewriting everything else, I now can simplify what is inside those parentheses to get a trinomial there. So we'll have f of x is equal to 4 times x squared plus x minus 2, and then we have times x minus 3. Now we're going to take that trinomial and multiply it to the binomial. The way I like to do that is to take each term of the binomial and multiply it to all three terms in the trinomial. So we'll take x and we'll multiply x to x squared, to x, and to -2. So we'll have f of x is equal to 4, open parentheses, x cubed plus x squared minus 2x. And then I'm going to take the -3 and multiply that constant to all three terms. So I'll get -3x squared minus 3x plus 6. So now I can simplify like terms. So I have f of x is equal to 4 times x cubed, and then we have a x squared and an x squared term, which combines to be -2x squared. We have a linear term of -2x, and negative 3x, which combines to be negative 5x, and then we have plus 6. And now we distribute the leading coefficient to get a final answer of f of x is equal to 4x cubed minus 8x squared minus 20x plus 24. And so that function, when solved or when finding the zeros, will give you zeros of negative 2, positive 1, and positive 3. All right, guys, I hope that was helpful. Good luck.